Hey, Calc BC, what's up? Thanks for coming back. We're still in the middle of our derivatives review, and so we're going to keep right on rolling. So a little different than AB, we're going to keep going with the kinds of functions that we know how to derive and the rules for differentiation. We'll loop back later and go through applications of derivatives. So what we're going to look at today are a couple more functions that we know how to derive, and look at some of the implications of the rules that we already have now. So with like product rule, chain rule, quotient rule, and how that impacts some of what we're looking at. So I want to jump right into it, and I'm going to start off with logarithmic functions. So specifically the natural log function. So this is down derivatives for logarithmic and exponential functions. And so just a real quick review for everybody that the logarithm that we're going to use, right, most of the time, what we're talking about is that f of x is equal to like a natural log. Let's just say natural log of x for right now. And I want to remind us that you know, all the rules for logarithms are still going to be important. But one of the biggest ones is the change of base formula. Because if f of x, you know, if g of x is some other log base b of x, you know, I don't want to worry about memorizing another rule for log base b of x. Like, that's dumb. Why don't we just convert this back into natural log? And so your change of base formula is going to be super helpful here. So just a reminder that if you want to change the base of a logarithm, right, log base b of x is natural log of x divided by natural log of b. So yeah, basically just change the base back to natural log, because then you only need to worry about one rule. You know, if f of x is natural log of x, then f prime of x we know is 1 over x. Okay, and if it's not just x, right, now we have to consider the chain rule, because you know we know the chain rule exists. So if f of x is actually the natural log of some function of x, right, then you'll remember that f prime of x is u prime over u. So it's the 1 over u, but then with the chain rule we have to multiply by the derivative of u, so that's u prime. So that's the derivative rule for logarithm functions. Okay, and if it's a log that's a different base, change it. You know, don't deal with log base b. Make it natural log of x over the natural log of b, because 1 over the natural log of b, that's just a constant. We can move it out of the way so that when we go to derive it, you just have 1 over the natural log of b times the derivative of natural log of x, which we just reviewed as 1 over x. So quick and easy review of our natural log functions derivative. I think the bigger thing here is to just remember that when we get a base that's not natural log, we're always going to change it back to natural log so that we can apply the natural log rule. That way we don't have to worry, you know, waste a lot of brain cells trying to memorize formulas that we don't really need, because we already know how to change base. We learned that a long time ago, probably back in algebra 2. Now exponential functions. Let's put up some exponential functions here. Oops. You know, similar idea. You know, I think that everybody's favorite function in the world to derive is e to the x, just because it's so nice and easy. So let just quick. I mean, if y, oops, I lost my pencil there. If y is equal to e to the x, then dy dx is just good old e to the x. And I think that we all appreciate the fact that the derivative, the rate of change of e to the x, is just equal to the y coordinate at that point. You know, if it's a function, if it's not e to the x, but it's e to some power that's a function, so u, where, you know, u is a function of x, then dy dx is going to be e to the u, but then you multiply by the derivative of the inside function, so u prime times e to the u. So yeah, basically same idea as before. We have the basic and then we have the chain rule version. What if it's not e as the base? Change the base. Yeah, exactly. Yeah, there's a change of base formula for exponentials too. Yeah, if you want to change the base of an exponential, you certainly can. It's a little bit different, in exponentials, because if it's like a to the, let's just say x power for right now, if it's a to the x power, then what you can do is you can go e to the natural log of a to the x power. Now, I would say that inside that exponent now, you can use the rules for logarithm that say, hey, that's, oops, lazy, I forgot to write natural log there. Come on. If you put natural log of a up there, where can that x go, right? Yeah, it just comes down in front. And that's nice because then the natural log of a is just a coefficient. And it's constant, right? A is a constant. So if my new function, let's just go down here, if y is, let's just say it's a to the x, and we rewrite that as e to the x times natural log of a, then dy dx, of course, is, well, it's just e to the x natural log of a. Now, what's the derivative of x times the natural log of a? Well, x derivative is just 1, so there's this natural log of a term in there because it's 1 times that constant, which of course you could reduce that to the natural log of a to the x, because e to the x natural log of a is a to the x, and so there you go. There's your derivative for the exponential. That's pretty much it for this assignment that we're working on today. Last week we reviewed all the basic differentiation rules that work for like polynomials and stuff, and rational functions. So now we're going to kind of build up on our function, the repertoire of our functions that we know how to derive. To the point then, by the end of this week, we will have, if you flip to the front cover of your book, there's all those derivative rules there. We'll have all those derivative rules reviewed, so that we can loop back then after. We'll take a little quiz on that next week on the 12th, and we'll come back then and start looking at applications of derivatives. So that's all I have for you today, guys. Like I said, these derivative reviews are going to be pretty quick hitters when it's just the rules. When we do the applications, we'll go through some applications. We want to redo related rates, and we want to redo optimization and all those good things that, when we start applying this knowledge that we've just learned, it did go a little slower. So anyway, thanks for watching, guys. I know it's a quick video. That's great, right? So short homework, and I'll see you in class. I'll see you in class on Monday. All right.